Good afternoon. This is our second problem from chapter 6. I'll be showing problem number 6.7 today. I've got the free body diagram drawn up there. I'm going to talk a little bit about it. The problem statement is to find the internal forces for each of the members. There are 5 members. Member AB, AD, BC, BD, and CD. So that's our problem statement, to find the internal force for each of those 5 members. In order to do that, we need to find the reactions at the 2 supports. So we had a pin connection at A. Pin connections provide an X and a Y. We also had a roller at point C. The reaction to a roller is a force parallel to the surface that the roller sits on. That surface was perpendicular to member CD. So the fact that it's perpendicular to member CD is why that roller, this dark blue line, is at a 90-degree angle, to CD. I do know that ultimately we will need to do the calculations for CX and CY. So we'll need we will need the angle. And we'll kind of work through that as we work through the problems. So for example, I'm going to start by taking a moment about point A. I'm going to start by taking a moment about point A. Because I have too many unknowns to do the summation of the moment, the summation of the forces in the X direction. That would give me, I'm left with CX and AX. I've got too many unknowns to do the Y direction because I've got 2 in the Y, AY and CY. So if I take a summation, now just kind of watch what I'm doing here. I'm going to take a summation of the moments about point A. That renders AX and AY as non-players. Now the 18 Kip force. The 18 Kip force is a player. The perpendicular distance between point A, which is where we're taking our moment, and where the force is being applied is 9. So 18 Kips times 9 feet, and that's a player. 15 Kips is not a player. 15 Kips, the line of action is through point A, so the perpendicular distance would be 0, so not a player. CY is a player. The perpendicular distance between CY, where the force is being applied, and our point of rotation is 9 plus 9, which is 18 feet. And CX is also a player. And that distance between CX and our point is 12 feet. You might say to yourself, hey, Rick, I'm looking at the board. I'm noticing that you have 2 unknowns, CX and CY. So we'll reconcile that in a second. We'll kind of talk about what that actually is. So CX is equal to whatever the value of C is times the cosine of 3687. CY is C times the sine of 3687. So substituting those values in, again, we said CY is equal to, so it'll be 18 times C times the sine of 3687. and CX 12 times C times the cosine of 3687. Before we get too much further, let's go ahead and grab the directions. So if I'm at point A and I have 18 kip force pulling down, that's going to create a clockwise motion. 15 was not a non-player. CY would create a counterclockwise motion or rotation, and CX also creates a counterclockwise rotation, so positive. I'll update my rotation signs real quick.